right, well, welcome aboard. It's our science lesson. I'm very excited about this one. We have so much to do. So in the in the chat, you can join the Nearpod. So I have placed it in the chat and we'll continue to put that in there so you can join and be ready, okay? In the meantime, while you are joining, let's get started. And yes, I don't have a background today. Look at that, you're in my studio with me. Hey, but there's a reason for that, okay? So I have something to show you, so I have to keep my background off. Now, let me see, who was our, oops, somebody else is joining. Who is our teacher helper? Ooh, is she here today? I don't see Viviana. We need a substitute. Ooh, let me see. Oh my goodness, Mackenzie, look at your hands. All right, Carl, go ahead.
Participate, be respectful, on time, microphone is muted, include full name in Zoom, stay seated, eyes on me.
Wonderful. Man, that was fast, and thank you for being an amazing Zoom promise keeper. Do you want to continue? Let's do our calendar.
Today is Wednesday.
Tuesday. Whoops, it says Tuesday. I messed up.
I got confused. Today is Tuesday, February 21, 2023.
Nice, thank you. Sorry to mess you up like that. And yes, it's Tuesday. I need to move that little circle over. And here's how you write it, or the date code 2/21/23. Who are our weekly spotlight friends? Ooh, we have Lucian, our awesome Zoom promise keeper. We have Viviana for amazingly detailed responses. And we have Miss Mackenzie for working hard. Wow, everybody's happy for you guys. Excellent job. Keep up the good work. Our birthday celebration for the entire month of February is Miss Desiree and Miss Madison. Yes, I'm talking fast. That's because we have a lot of good stuff to do. Look, what are we doing? What are we doing today? Today we're learning about magnets. Yeah, we have so much to do with magnets. We're going to demonstrate that magnets can be used to make some things move, even touching them. So let me ask you a question. Anybody want to raise their hand and share their thinking? Can you make a connection to the force of magnets with another force? Ooh, Emmy? Emmy, yeah.
So a force of magnet can attract, but if it's one of the same kind, it will decontract and go the other way.
Does that remind you of any other force that we have been learning about? Phone a friend? Anybody want to ask? Addie, go for it. Think something about you've been learning about something else that has force.
Magnets have magnets have force, and if you put north to south, that attracts it. If you do north and north, that doesn't attract.
Very good. Can you think of another thing we've been learning about that has something to do with force and motion? Besides
static electricity.
Static electricity, like her hair. Yes, electricity. Guys, remember we just learned a lesson about how electricity can make things happen, move. Yeah, there's a force with electricity. Very good. And our future learning, we're going to learn a lot more about magnets and how they force objects to move. Almost magically, almost. We're going to recognize that objects are pulled toward the ground using another force called gravity. And yes, that is Miss Mackenzie showing us static electricity. And we also have another friend that we are showcasing today. I want you guys to think about a few things while we watch the video. This is Emmy's student work showcase. Look what she made. Watch the video. Wasn't that amazing? While we watch it one more time, I want you to think about these 3 questions. Ready? Keep looking. How is that paper clip even moving? What type of force is being used on that magnet? No, not on the magnet, on the paper clip. What type of force is being used? And third question, why is the magnet attracted to the paper clip? Who wants to answer the first question? How is the paper clip even moving? Oh, Asa, how is it? Why is that paper clip moving?
Because there's a magnet under it, and magnet. The paper clip is metal, and magnets pull metal things.
Okay, thank you. What a great response. And I think he pretty much answered all of them, but who wants to try number 2? He said the paper clip is moving because of a magnet under the box. What force is being used? Ava.
The magnet under the box is pulling the paper clip
That's right.
while it's in the box.
Yes, it pulls. It has this pulling force. And thank you, Miss Ava. And the last question, why is the magnet attracted to the paper clip? Almo, why is that magnet attracted to the paper clip?
Because the paper clip is made out of metal. And
Mhm.
magnets are attracted to metal.
Awesome. Yes, and we're going to do an experiment today. Thank you, Almo. We're going to learn more about how magnets work. So it's today at the end of our lesson. By the way, we're going to do our Nearpod first. We're going to do about half of the Nearpod, maybe a little more. Oh, go ahead and mute. And next week, I will, this week, today, I'm going to demonstrate the power of magnets in a virtual experiment. You do not need to do anything. Hold on. This is my teacher demonstration only. Hold on. Second, here's the part that's going to concern you guys. In just about 2 weeks, you will prepare your investigation that is due March 7th. What are you going to do? You are going to make a sensory magnet bottle. So this is optional. You don't have to do it, but if you want to, you can make one. And then on March 7th, it's due that day. Okay, not after, not before, on that day, we will present, everyone will show their bottles and show how the sensory magnet bottle works. I sent in an email some information, some video, and some instructions and materials so that you can go ahead and do it. Now, while you're logging in and I'm meeting you there, I know Miss Mackenzie had a question. Go for it, Mackenzie.
I thought that was the Nearpod, but I was just gonna say the Nearpod is not letting me go, and it's just saying wait for the teacher to start the. I know. I was about to put that in the chat, but I just didn't.
Okay, let's see. I see Ava and Leon in. Keep trying. And maybe we
I'll log out and try to log back in.
Okay, that's a good idea. Thank you, love bugs. All right, so what we are about to do now, since Nearpod is not cooperating with us, we are going to skip the Nearpod for now, and I will send it to you later today to attempt to log in and practice learning about magnets. But for now, get out of the Nearpod and give all your attention to the screen, where you are going to see an experiment. Now you can do this experiment at home as well. You may click the view button at the top of your Zoom if you want to make my screen larger. So here's what we're going to do. I'm going to change something here. Whoa, you can see my, my experiment. There's my hand. There's my bowl. In today's experiment, we are going to learn more about the power and force of magnets. Anybody know what that is? You do know? Oh, Miss Madison, what is that? Sitting there in my bowl.
Cereal.
It is. It's cornflakes. Why in the world would I have cornflakes with a magnet experiment? That's the question, right? So today our lesson is going to be how we can extract, pull out metal out of our cereal. What? Did you know that when you're eating cereal, many cereals that you eat have metal in them? So tiny that you can almost not see it at all. Well, one way we can find out if our cereals have metal is to get a magnet and test to see if it attracts, if the cereal is attracted to the magnet. That will prove something. What will it prove, guys? Oh, who wants to discuss it while I pour water in? What do you think a magnet pulling on cereal will prove? Let's try Ava and I see, let's do Emmy. Ava and Emmy. While they're talking about what's going to happen, I'm going to pour water in my bowl. Okay. Go ahead, guys.
It will move around. It's because it is floating and it's not reaching the plate.
Yeah. But I'm kind of confused. Well, it's iron in your cereal, not magnet.
You know that, don't you? Iron? What's iron, McEmmy?
Iron is like a type of metal.
Yes, it is. It's actually an essential mineral. You remember when we talked about soil, how there's minerals and nutrients in soil?
Yes.
A mineral is something that's found in nature, and it's essential. It means it's absolutely important to your life. What? Yes, if you don't have iron in your body, something, you could actually suffer with some problems. Did you know that iron in your body helps transport oxygen in your blood? That's right. Can you imagine if we didn't have enough iron? We would be anemic. We would not feel good, guys. So here's what we're going to do. I have this cool magnet. Look at my magnet. This magnet's really neat. It's got a handle on it and a very strong 10-pound magnet. So if it doesn't attract the cereal, what would that mean, guys? Who wants to tell me? Who wants to discuss? Asa and Mackenzie, what would happen if this does not attract?
There's no iron in the cereal. There's like no metal.
Asa?
It wouldn't attract if there's nothing metal inside, and it might not attract because it might be
What's happening?
it's moving with your magnet
Why?
because there's iron in it.
There's iron in it. It's so tiny. It's kind of hard to pull it. There's only a little bit in there. In the Nearpod, I had a picture of the cereal box and the nutrient panel, like all the ingredients and what's included in your cereal. And it told me that there were 12 grams, or 12 grams. Is that right? Let me look. My cereal box says iron, 12 milligrams. Yeah, I was going to say grams are too big. 12 milligrams in the whole box. Oh, it's so cool, guys. It actually pulls the cereal. So let's talk a little bit about the cereals that you eat. In the Zoom chat, tell me a cereal that you eat. Name a cereal while I do the next part of the experiment. I want to see.
The cereal.
Type it in the chat. Please don't unmute like we discussed. Thank you very much. While I do the second part of the experiment, I would really kind of want to see if I can pull the iron out of the cereal and actually see what it looks like. That's what we're going to do next. Wonderful. Ooh, Fruit Loops, Cheerios. Oh, Ben, what's that? Frosted Flakes? Is that Frosted Flakes?
No.
What's that?
That's Fruit Loops.
Fruit Loops. I should know that. That's good stuff. Cinnamon Toast Crunch, mini wheats. Oh, wow. Those are all great cereals. I love cinnamon. So if you look at my screen, I'm going to pull this up a bit. You can see on the sides of your cereal boxes, have you ever noticed the ingredient and nutrient panel on the sides of your cereal box? Yeah. If you ever take a time to look through it, it will tell you exactly what's inside and included in your cereals. And here, down here, it says iron, 12 milligrams. Oh, not in the whole box. It's in 1.5 cups. I don't think I eat 1.5 cups. Okay, let's do the second part of our experiment. Now, the next part is I took the cereal and I smashed it up and made like almost like a little slurry of it. Okay. And I put water in. I also did one with milk. I put milk in cereal and water in my cereal and mashed it all up. What am I trying to do here? Anybody know? What am I gonna try to do? Let's see. Who else is there? Come on, I need another hand. Hi, Desiree. Hi, Isaac. Let's see, Ava. What do you think I'm gonna try to do with this water?
Make it magnetic.
Ah, okay. Am I trying to pull something out?
Yes.
Oh, okay. Listen, if I break up the materials, sometimes we talked about this a long time ago, how when you make a mixture, sometimes you can pull it apart again, and sometimes you cannot pull it apart, right? Think about your smoothie. Once you make a smoothie, can you pull the banana back out? No. But in some cases, we might be able to pull the iron out. Pull some of the ingredients back out again. Can anybody see anything already that's floated to the top? That looks like it could be iron. You get a little closer. Anybody see anything? Mackenzie thinks she sees something. Addie, what do you see?
I see a tiny black dot.
You do? Do you think it?
Yeah.
Oh, I see one too. Do you think that the magnet will make it move?
Yeah.
If it makes it move, Benito, what do you think that means? Do you see that little tiny black dot right there? If the magnet moves it, what does that mean I pulled out of my cereal?
The metal is coming out of the cereal.
Whoa, is that what happens in your body? Does your body pull the nutrients out of your food?
Yeah.
It does the same process. Well, similar process. Okay, let's test it out, guys. I'm gonna see if I can make this little black speck move. All right, boy, this is gonna be tricky. Let me get it wet. Is it working? Guess what? It's not working. Maybe it needs more water. What do you guys think? Should I put more water in? Okay, all right, let's do that. It may be so stuffed full of cereal, it can't move. Let's try adding a little more water. Water around electronics is probably not the greatest idea. Okay, let's try it. Let some air out. Who wants to unmute and talk about the power of magnets? Okay, let's partner up a few people. How about, I see a hand from Mackenzie and Emmy. You go first. I'm going to see if I can, I think I can pull some out. Go ahead. Was it Mackenzie and Emmy? Talk about the power of magnets, what they do.
If a magnet attracts to a magnet, one of them should move the other, and they should attract to each other. So then they stick together. Yeah. Plus, if you put the magnet on it, it might move like attract. But if it's one of the same kind, it will decontract. But if it's another kind of magnet, they'll attract. It's like iron. It moved.
It did move.
It moved.
It did. That must be a little tiny bit of iron. Let me see if I can get any more. All right. Emmy, would you pick the next two people to discuss the power of magnets and the force of magnets? Who would you like?
Elmo and Addie.
Almo and Addie. Unmute, guys. Time to discuss.
I have two magnets.
You do? Talk about it.
When I do the blue and blue, that when I do the blue and blue, it won't let it attract. So if I do blue and red, it will attract. And if I do red and red, that won't attract.
Almo?
Okay. So these are two metals that are the same. So when I attack them together,
Nice. Anything else?
and with the metal, it attracts the little piece.
Mm-hmm.
With the metal, it attracts the piece.
Because it's made of?
Metal.
Very good. Okay. What do you guys think about milk? Should we try this in milk? Who wants to talk about that? Ava? Do you think it'll have the same effect in milk?
No.
Why not? Who do you want to discuss that with?
Mackenzie.
Okay, go for it.
I think it will work because it's liquid as well.
Okay. All right. Anybody else? Let's see. How about Carter? Carter, would you like to discuss? Eek, this looks really smushy. Yuck. Is this what happens to your cereal? Does it get all mushy like this? Okay, hold on.
He doesn't like cereal.
You don't like cereal. Anybody want to try this at home? Yeah? With your cereal? Now, what would happen if my magnet wasn't strong enough? Are there magnets that are strong and some that are not as strong enough? Asa?
If your magnet wasn't strong, then it wouldn't be able to move that little piece of iron.
Yeah, that's true. I'm wondering if that's the case here. What do you guys think? Do you see any? Do you think some cereals have more iron in them than other cereals? Yeah? Oh, wait, what's that? Do I see something? Is it harder to see in the milk? Mackenzie, do you think it's harder to see in the milk?
Yes, because I don't see any. All I see is like,
Bubbles.
yeah, I don't really see the cereal.
So when you're doing an experiment, you might come across some results that you're not happy with. Maybe you're feeling like you need to redo parts of the experiment. Would this be something that you think we could revise and do better? Yeah. So and the other thing I was going to mention to you is when you're doing an experiment, you should be collecting data. What data do you think we would be able to collect? Who wants to discuss that? Ooh, let's see. How would we measure how much iron we're pulling out? Let's try Emmy and Leon. Go for it. How would we collect data on this?
Well, data is like the well, when you like smooth it, it's like the water begins to like, get smooth, and then data is like, you know,
Emmy?
I think
produce
that
magnetic.
was what I was gonna say.
Well, what is data? In all the feedbacks, I'm telling you guys, wow, you analyze the data, you collected. What is it?
Data is like the thing that like what you collect, how much measurement it is, or like
Ah, guys, look at that.
Hey, that was my answer.
It's great, Leon. Measurement, that's data, numbers, or some type of
It's
information.
data and numbers.
Yes,
It's a lot.
thank you. Now,
It's
go
a
ahead
lot,
and mute
Mackenzie.
in 5, 4, 3, 2, 1, and how would you measure how much iron? Who wants to discuss that? Ooh, let's try some. I see Desiree there. I see Carter hasn't talked. How about Isaac? Or Ben? Do you know how you would measure this? How much iron is in a cereal? Who wants to talk about it? Ava, pick a friend.
Emmy.
Go for it.
What are you supposed to be talking about? I don't. Magnets.
Oh, sorry. The question was, how would you collect and measure data to determine how much iron is in the cereal?
You measure data. It's how you make an experiment. You can collect the data, but maybe you put it in a bowl or something, and then put your magnet in the bowl and pull it out and see what comes out, and figure out how many comes out and put it on a data chart.
Okay, who's your partner? Who's talking with you? Go ahead, Ava.
I think that you can pull the iron through the cereal with the water and the milk.
How do you measure it? Measurement is like how much, right? How would you measure how much iron you pull out?
With measuring tape.
Oh, okay. You can measure it with measuring tape. Can anybody think of another way?
Scale.
A scale. Okay. All right. Call on a friend. Who else?
Isaac.
A measuring cup.
Oh, you could do a measuring cup. That's good. I like that. Excellent answers, guys. Let's see. Isaac, call out another friend. What would you write it in? What would you write your
Addie.
What would you write your data in, Addie?
On a piece of paper.
Oh, okay. Would you just like put it on all different, you know, not how would I say that? Just kind of, oh, I see some. I see some. Look, it's down here at the bottom. Would you
I
just
see some too. I see that.
would you I wonder how oh look, it is. It is.
I see a little black dot.
Yeah.
I see it too.
Oh wow, we are finally pulling out some iron. This is taking a long time. Good thing we didn't do our
see
Nearpod
the dot.
today. Nope, I lost it. Okay, so for the last part of the experiment, let's bring back our bowl and a nice fresh piece of corn flakes. And then we'll see if we can get it to dance for us. And okay, it's got some old pieces in there. Can you see the bowl? Let's put some new fresh pieces in. How many pieces should I put in? Show me with your hands. How many pieces? 5? Okay, I'll do 5. All right, you ready? Ooh, there's a big one. Little one, little one, little one, little one. Okay, here I go. Whew. Can you see it? Oh, it's attracted to it. No way. By the way, guys, while I'm showing you this, oh my goodness, look at that. Look. The magnets that you are using, you need to be very careful with them around electronics, telephones, computers, and also credit cards, because magnets can actually, you know how it can take the iron out of a cereal? It can actually take information and mess up your stuff. So please be very careful not to let magnets near electronics or credit cards, okay? Debit cards. I wonder, are you going to try this with your Fruit Loops? Raise your hand if you have a magnet at home. Oh, you do. That's wonderful. So here's what we're going to do at this point. So in the Zoom chat for your exit ticket, the Zoom chat, I would like you to tell me something that you learned about the force of magnets. Now, oops, there's a couple of them. Let me let Addie back in. There's a couple of things I need you to remember. Because we didn't get to the Nearpod, let me review a few things about magnets. It is in your curriculum. It is in your lessons coming up. So if you haven't done it yet, you're going to learn so much. If you've already done it, you're going to have a quick review. First thing I want you to know about magnets is that it is a force that can either push or pull. Magnets generally have poles or polar sides. So they either have a north pole or a south pole. Poles that are opposite will be attracted to each other. So if Ava took a magnet and her north side of her magnet and Carter had his south side of the magnet, if they put them together, they would go and they would snap together. They would be attracted. However, if Carter flipped his over and his side was north and Ava's side was north, they would not be attracted. They would call what's called repel. They would repel. Ew, repel, get away from me. They would push each other away. So the thing that you need to know is attracted pull or repelling push. Okay. The next thing you need to know about magnets is that it can force objects into motion. And let me see what else. Oh, yeah, of course, we did learn that magnets can force objects to move, and it can actually extract or pull out metal from a solution, even from the sand. I saw once this person had a giant magnet strapped to like this box, and he had headphones on, and he was walking on the beach, and every time his big magnet touched or sensed something metal in the sand, it would go beep, 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 beep. And he would dig in the sand and he'd pull up something metal, and it could have been a necklace or a ring or an old can. It could have been anything.
I heard of those before.
Yeah, they're great. They're like
Me too.
for treasure hunters, right? So, but that's a pulling force. Magnetic force is something that is natural. Okay. There is a natural magnetic force on the earth. So now that you know a few things more about magnets, before you leave, type something in the chat that you learned, or you can unmute if you raise your hand. Okay, something that you learned. Yes, thank you, Mackenzie. And if you're done, you can go. Emmy, go for it.
There's a magnet at the bottom. Try looking at the bottom. I see tons of black things.
Really? Oh, I see it too. Look at that. Let's see. Oh my goodness, it made it move. You can't see it. It's so tiny.
I'm
But
on it.
Yeah,
I'm in it too.
very good. Oh, okay, thank you.
Cruz, I got something to show.
All right, go for it, Leon. Leon, if you have something about magnets? I wasn't sure what he was doing, but this is your exit ticket. And tell me something that you learned about magnets. Go ahead, Mackenzie.
It's moving the
Thank you. Go ahead, Mackenzie.
That there is metal in cereal. I did not know that.
That's
In one of the
right.
lessons, it said that, and me and my mom did not understand. And now that you are talking about it, I did not know that.
It's really interesting that they put.
I didn't know either. It was really crazy.
Yeah, they actually add in minerals into our foods so that we can stay healthy, and you can extract them, pull them back out if they're metal using magnets. Excellent. Thank you. Thank you. Who else? Asa, what did you learn today? Oh, what did it say? What did you write in there? Asa, try again. What did you write?
I wrote iron.
Iron. Very good. There's iron is attracted to a magnet. Very good. Thank you. Thank you. Desiree, what did you learn today? Ooh, north repel.
Iron is metal and is in cereal.
Fabulous. You're awesome. Thank you so much. Who else would like to tell me? Oh, I like all this stuff I'm seeing. Yes, Mackenzie, you're all set to go. If you've given your exit ticket either in the chat or raised your hand, you may go. Carter, what about you? Tell me something that you learned today about magnets.
I learned about magnets because whenever you put like a magnet to something like metal, or then the metal will come touch the magnet and it'll stay on.
Yeah, that's called attracted. That's right. It's pulling because it's attracted to it. Very good. Thank you, Carter. Isaac, what'd you learn today? Bye, Addie.
I didn't know metal in my food or my cereal. Now we'll look at the label to see what in my food.
Yeah, that's great. Excellent job. Thank you, Isaac. Ava, I'm ready for you.
And also, some magnets can't stick to each other because they try like going away from each other and they don't like each other.
They repel. Ew, repel. Gross. They push each other away. That's right. All right, guys. Olmo, you can go. Did you? Yep, you did. Thank you. Yep, Serial has medal. Desiree, you're free to go. Carter, you can go. Leon, you can go. Isaac, you can go. Ava, you can go. Emmy, you can go.
I love you, teacher.
Bye.
Bye.
Carter.
I'll send the
Bye,
note.
Emily.
Bye. Leon, what were you going to say?
I was saying that the magnet moves like this.
Oh, I can't see it. I only see your arm. Show me. Move the camera a little more. Oh, he's going to give us a demonstration. Look at that. Very good. Thank you, Leon.
No,
What a
no, it moves. See?
scientist. It does. Oh, that's
Moves all
cool. Are you going to make the sensory bottle? Can't hear you. I can't hear you. No? Okay. All right. I'll let you go. Bye, guys. Take care. Bye, Carter.